Hi, my name is Rob Risany. I'm the Worldwide Innovation Executive for IBM Watson IoT. So I'm here today at the IBM ADLINK solution booth at Intel IDF, and we're showcasing the PMQi solution, which is a really exciting release that ADLINK's taken to market, coming out of the collaboration between Intel, IBM, and ADLINK as part of our IoT Innovation Factory program. This is a first of a kind, first to market industrial solution designed to ease the deployment of predictive analytics from the cloud all the way to the edge. Let me tell you a little bit about how it works. What we have here is a simulation of a conveyor system that we see operating in a lot of industrial applications around the world. And as such, it's a really good representation of the way that advanced analytics and cognitive solutions can be deployed into factory applications. So what we have here is this conveyor is running, and it's actually being operated by the cognitive gateway, which is built on an ADLINK MXC200, which is an Atom-based Intel gateway that's equipped with the IBM Watson IoT platform. And what's exciting about this solution is it not only is capturing data from all of the sensors that are operating this, but it also has predictive models which control the behavior of this conveyor to deal with shock situations where it might be having problems. You know, the reality is that predictive maintenance and quality is known as one of the best applications in industrial IoT for using sensor-based data to deliver value. Let me show you how it works. In this case, this conveyor is running and we have a number of sensors that are running on it. You can see the display here on the screen. We've got a temperature sensor right here. We've got a vibration sensor right here. And we have a voltage meter attached right to the motor. And we've got a tension meter, a force meter, which is simulating effectively, say, tracking the packages or product that's going along on this line. Very similar kind of approach that we see with large logistics companies in the market today. So what's going on is that this system is being controlled and the speed is regulated by the predictive models running on the gateway. The models are actually built off of the data that comes off of the system, and importantly, they learn from the behavior of how this conveyor behaves, and they dynamically adjust the behavior of this conveyor based upon the stresses on the environment. Let me give you an example. Here we've got this little weight meter, and if I put extra weight on it, you'll notice that the force tension meter goes up significantly, and it says that it's elevating the risk and adjusting the speed. Now, as you come down and you listen to it, you can actually hear the conveyor and see the conveyor moving, much slower as we raise that. In fact, here I'll do that with my mouse and you can really see it. If I push that down, it starts to really slow down quite a bit. Well, it's not just individual sensors that cause the challenge, it's the combinations of sensors. And that's because we've taken predictive models built with the Watson IoT platform and we've actually embedded them onto this gateway. So if I, for example, take this heat gauge and heat it up a little bit, as that temperature spikes, for example, if I put it right here on the control system, that'll actually adjust the temperature as well. If I add vibration by bonking the vibration sensor, I can create all sorts of increased stress on it, and it'll actually slow down, even cause an emergency stop on it. This is a really good example of the kind of systems that are being deployed in real factories using ADLINK PMQi. What's great about this system is it reduces the cost of deployment of predictive maintenance solutions by more than 30% versus traditional build from scratch approaches. And it's built combining the technologies of Intel, ADLINK, and IBM. So it's really a great example of what happens when we collaborate together in this ecosystem to create new approaches for industrial problems. Clearly, as we've been going through and we've shown how the system works, we've seen some of the indicators that somebody might use in a condition-based monitoring approach. But behind the scenes is the Watson IoT platform running on the edge. It's integrated in with the rest of the potential infrastructure that might be running in a client's environment. Here you see the Node RED environment that's actually running on the gateway, and we're taking the data off of this environment and streaming that data right back into the system, and that's what's making the adjustments on the fly. This is a self-healing conveyor. So So what I mean by that is the predictive models are literally monitoring what's going on with the sensors and then adjusting the speed dynamically. There's no manual controls on this. It's all controlled, dynamically, basically using the clicks. There's no mechanical switches. It's all controlled by the environment. The integration of solutions like this into factory environments is often very challenging. The deployment of these systems usually requires a deep collaboration between IT organizations and OT organizations. And what PMQi is all about is closing that gap between the IT and OT organizations. By having a system that has industrial ruggedized computers that can be dropped into an OT environment and already be pre-configured with the IoT-based analytics necessary to consume data off of these sensors, we've got a lot better ability to have success in a deployment. Other hardware involved in the solution are the AD converters that ADLINK provides. These are built on reference Intel approaches for dealing with vibration, dealing with any type of amperage monitoring or voltage or heat sensing. And these are often deployed and equipped right out into the factory floor or embedded into equipment.